Alright, let's dive into what I like to call the digital divide, understanding computer science versus computational thinking. So here's the thing. When we think about education in tech today, there's often a massive misunderstanding between computer science and computational thinking strategies. They're like two sides of the same coin but utterly different, like how you wouldn't mix apples and oranges, right?
Wow, so they're connected but also really distinct. That makes sense. So what exactly do you mean by computer science focusing on like programming and algorithms?
Great question. Computer science is all about the essentials of digital systems. Imagine you're a chef. You need to know how to cook and what ingredients work together. Similarly, in computer science, you learn how to design, develop, and evaluate computational solutions. This means coding, debugging, understanding networks, cybersecurity, and now, of course, the rise of AI. You're building the tools of the future, much like a chef designs a recipe.
Right, so is it like when I try to code a website and like everything crashes? That's debugging, isn't it?
Exactly. You've hit the nail on the head. Debugging is like discovering your soufflé has flopped. You have to figure out where it went wrong. And this is crucial in learning. Coding is inherently about problem solving. But let's not forget about computational thinking.
I'm really curious about that. So, computational thinking is different, right? How does that actually apply in classrooms?
Yes, indeed. Computational thinking isn't a subject of its own. Think of it as a toolkit, a methodology that boosts your problem-solving skills across the board. It involves techniques like abstraction, decomposition, pattern recognition, and algorithmic thinking. So if you're working on a math problem, for example, you'd break it down into smaller, manageable pieces. It's like being an investigator piecing together clues.
Like a detective, but for numbers. Do you have a real-world example where this method is used in school?
Absolutely. Picture this, you're writing a story and you need to structure it. Instead of just diving in, you decompose your thoughts, outlining the beginning, middle, and end, recognizing patterns in characters or themes. This reflection parallels coding, where you create algorithms to solve a problem. Both skills scaffold your understanding.
Oh, so it's like a toolbox for thinking better?
Precisely. It's about enhancing your cognitive skills instead of just learning a standalone subject. Teachers can integrate computational thinking across all subjects. It's about fostering logical thinking in literacy, numeracy throughout various areas.
Wow, that's a game changer, isn't it? I mean, if teachers start using this method, it kind of changes the learning experience completely.
You're absolutely right. And by embedding computational thinking in the curriculum, educators can guide students in using algorithms in maths or breaking down complex writing tasks. The potential for practical application is massive.
But how can teachers effectively do this? Like, what kind of digital tools should they use?
Great follow-up. Teachers can utilize a variety of digital tools. Think coding platforms like Scratch for younger learners. It can help students visualize code, enhancing their understanding of concepts. Also, incorporating real-time coding exercises can bring that direct experience. It helps solidify their knowledge of both computer science and computational thinking.
This is fascinating. So it's not just about tech skills, it's also about preparing students for like everything they could encounter in life.
Exactly. By honing their computational thinking, students become more adept problem solvers, ready to tackle challenges, be it in technology or other areas of their lives. It's a foundational skill.
Thank you for breaking it down so engagingly. I can totally see how this would shape future innovators and thinkers.
My pleasure. Remember, the bridge between computer science and computational thinking leads to a richer understanding and flexibility in learning. It's about empowering the next generation to think outside the box.
I can't wait to see where this incredible journey takes us next.